Hi, my name is Andrew, and today I'm going to be talking about the importance of performing quality control in high-throughput sequencing data. In this RDMbite, you will learn about how poor quality sequencing reads may arise and how QC fits within the overall pipeline for analyzing sequencing data. As with all data science, sequencing data of poor quality can impact downstream analysis and interpretation. This can affect the sequencing reads directly, highlight technical issues with the sequencing run, or problems accessing, downloading, or copying the data. If you're working with new short-read datasets, it's unlikely that QC will show any major issues. Illumina sequencing machines typically return 75 to 90% of their reads with average quality scores over 30, meaning that there is less than a 1 in 1,000 chance bases are incorrect. Modern aligners and variant callers also now take into account per base quality and can often ignore issues in the data. However, working with long-read sequencing data, older datasets, or samples from poorer starting material are all more likely to show problems in QC, and systemic biases and large proportions of poor quality data can impact your analysis. FastQC is one of the most commonly used tools for generating QC reports on individual sequencing data files, and multi-QC is increasingly used to summarize QC from multiple samples into single plots. Both tools are very easy to install and run at the command line. ReadQC doesn't generate any new data, but rather summarizes all the information contained across a single FASTQ file. Read location on the flow cell is stored within the header, as well as some on the sequencer filtering QC on more modern sequencing machines. All other statistics are based on the raw sequence and the per base quality Phred scores. After assessing an individual FASTQ file, FastQC aggregates multiple metrics into an easy-to-interpret HTML file you can load in a browser. Different metrics, shown here in summary, are also given a traffic light system. Take these with a pinch of salt. Some metrics are heavily reliant on each other, such as duplication levels and KMA content, and others exhibit technology-specific biases. In the next RDMbite, we will cover what each of these metrics means, and what you may or may not need to do to filter and improve your data. Essentially, QC allows you to choose your next step. Either the data are great and you can carry on, or you may need to perform some further processing. This usually includes trimming reads, where poor quality sequence is removed from typically the 3' end of the read, or removing entire reads from the data. In essence, sequencing data QC helps you to answer whether the data is worth precious time in analyzing further, and whether it will help you address your research aims. The takeaway message for now is that you should always run QC on sequencing data that is new to you, and you should even repeat it once any trimming or further processing is done. Recognizing trimming which may have already taken place is really important, so always chase any metadata if it's unclear. That concludes our initial look at assessing sequencing data quality. Take a look at the links associated with this video for more information, and the following RDMbites on FastQC metrics and read trimming.